In February of 2006, a caver exploring a limestone cavern in Schoharie County, New York, about 40 miles west of Albany, pointed a camera at a cluster of hibernating bats and took a photograph. The cave was part of a popular tourist system that drew hundreds of thousands of visitors a year, people who came from all over the world to walk its underground passages. It was meant to be an ordinary picture of an ordinary winter roost. But when the image was later examined, something was wrong. The bats had a strange white fuzz growing on their muzzles, a dusting of something pale and powdery across their faces, as if they had pressed their noses into flour. No one knew what it was. The following winter, when state wildlife biologists went into the caves of the region, they walked into a graveyard. The cave floors were carpeted with dead bats. Others hung from the ceiling, emaciated and dying, their faces and wings furred with the same white growth, and something else was happening that made no sense at all. In the depths of winter, in the freezing cold, bats were flying out of the caves in broad daylight, spiraling out over the snow when there was nothing out there to eat and nowhere warm to go. Behavior so abnormal that the biologists knew at once they were seeing something they had never encountered before. Alan Hicks, a bat specialist with New York's environmental agency, would call what was unfolding unprecedented, the gravest threat to bats anyone had ever seen. He was right. And it was worse than even he knew, because that single photograph from that single cave marked the beginning of one of the most devastating wildlife epidemics in recorded history. A killer that would sweep across a continent, wipe out entire colonies almost to the last animal, and drive some of North America's most common bats to the edge of extinction. And the strangest part of all was not that the bats were dying, it was how they were dying and what it revealed about a threat that no one had ever imagined could do this. To understand the scale of what was being lost, you have to understand what a bat actually does. There are more than 40 species of bats in the United States and Canada, and the ones dying in these caves were insect eaters, small brown creatures weighing less than an ounce. The kind most people never think about because they only fly in the dark. But those bats are among the most important and overlooked workers in the entire American landscape. A single little brown bat can eat thousands of insects in a single night, and across the country, night after night, the sheer tonnage of insects they remove is staggering. By eating the moths, beetles, and mosquitoes that would otherwise devour crops and spread disease. Insect-eating bats save American agriculture an estimated $3.7 billion every year in pest control, and by some measures, possibly far more, perhaps tens of billions once forests and every hidden benefit are counted. When bats disappear, the consequences ripple outward in ways that are easy to miss. Fewer bats mean more crop pests, which mean more pesticides sprayed across the land, which carries its own cost to water, wildlife, and human health. The little brown creatures in those caves were quietly holding a piece of the entire food system in balance. They are a free-living pesticide, patrolling the night skies over farms and forests, and almost no one notices they are there until they begin to vanish. To grasp how many bats were at stake, consider that a single cave or mine could hold a staggering congregation of them. Some hibernation sites in the Northeast sheltered hundreds of thousands of bats, packed together on the walls, and a few of the largest gathering caves in the country had, in the past, drawn animals by the millions. These were not scattered, solitary creatures. They were among the most densely aggregated, warm-blooded animals on the continent, which made them, without anyone realizing it, perfectly arranged for a disease to tear through them. And to survive the winter, when there are no insects to eat, these bats do something remarkable. They hibernate, gathering by the thousands, sometimes the hundreds of thousands, deep inside caves and old mines where the temperature stays cold and stable. There, they drop into a state called torpor. Their body temperature falls until it is barely above the freezing air around them. Their hearts slow from hundreds of beats per minute to just a handful, and they burn their carefully stored fat so slowly that a few grams can last them the entire winter. Everything about a hibernating bat is tuned to one purpose: to sip that fat as slowly as possible and wake up in spring with just enough left to survive. A bat in deep torpor is a marvel of biological thrift. Its metabolism throttled down to a bare flicker, breathing only occasionally. Its whole body a slow-burning candle, timed to last exactly until the insects return. Healthy bats do rouse naturally a few times over the winter, but only briefly and rarely, because each awakening is enormously costly, and that finely balanced system was about to be turned into a death trap. The white fuzz on those bats was a fungus, one that scientists would eventually name Pseudogymnoascus destructans, the destroying fungus, though it took painstaking laboratory work to identify it, isolate it, and prove, by satisfying the classic tests of disease causation, that this single organism, and it loves exactly the conditions that hibernating bats depend on. It grows best in cold, damp darkness, at temperatures between about 4 and 15 degrees Celsius, the precise climate of a winter bat cave. While the bats hang in their deep, chilled sleep, their body temperature lowered, and their immune systems all but shut down, the fungus does what no warm-blooded animal's defenses would normally allow. It grows directly into their skin. It invades the delicate, naked membranes of their wings, their ears, their muzzles, colonizing the living tissue of an animal too cold and too dormant to fight back. Worse still, the fungus does not even need the bats to survive. It can persist in the cold soil and on the walls of a cave for years after every bat is gone, lying in wait so that even a chamber emptied by death remains poison ground, ready to infect the next colony that dares to move in. If a story about a silent killer moving through the dark, and the scientists racing to understand it, is worth your time, take a moment to subscribe, because the way this fungus actually kills, once researchers finally worked it out, is stranger and more chilling than a simple infection. Because the fungus does not really kill the bats by eating their skin, it kills them by waking them up. As the fungus invades the wing membranes and irritates the skin, it disrupts the bat's delicate hibernation, jolting the animal out of torpor far too often and far too early. Every one of those unplanned awakenings is catastrophically expensive. A single arousal from hibernation can burn as much fat as the bat would normally use in weeks of sleep, and an infected bat may rouse again and again through the winter, each time torching a piece of the fat reserve that was supposed to carry it to spring. Bats with the disease burn through their winter fuel as much as twice as fast as healthy ones. And so, in the dead of winter, with no insects flying and no food anywhere to be found, the starving bats do something. They wake up and they fly out of the cave, out into the frozen daylight, searching for food that does not exist. They freeze, they starve, they collapse in the snow outside the cave mouths. Inside, the ones that remain waste away on the walls. In cave after cave, the disease killed with almost unimaginable efficiency, wiping out 90, 95, sometimes 100% of the bats that hibernated there. Entire colonies that had returned to the same cave for generations were simply gone in a season or two. And it did not stay put. From that one cave in New York, white nose syndrome spread outward year after year in a relentless wave-like pattern, bat to bat, cave to cave, and almost certainly carried farther still on the boots and gear of people who moved between caves without knowing what they carried. It crossed the Northeast, pushed into the Midwest and the South, jumped the Mississippi, and eventually leapt all the way to Washington State on the Pacific coast. Within roughly a decade and a half, it had reached more than 40 states and 9 Canadian provinces. The 3 hardest-hit species, the little brown bat, the northern long-eared bat, and the tricolored bat, saw their populations crash by more than 90% across the affected region. And the northern long-eared bat, once one of the most common bats in the eastern forests, was pushed onto the endangered species list, staring down the real possibility of extinction. Millions upon millions of bats were dead. By 2012, only a few years into the epidemic, the toll was already estimated at somewhere between 5.7 and 6.7 million animals and it climbed relentlessly from there. Of the roughly 47 bat species native to the United States and Canada, at least a dozen have been struck by the disease or the fungus that causes it, including several already listed as endangered or threatened. But as the catastrophe unfolded, the mystery of where this fungus had come from held a crucial clue, because scientists soon discovered that the very same fungus, Pseudogymnoascus destructans, was already living on bats across Europe and parts of Asia. And there, on those other continents, the bats were fine. European bats carried the fungus on their skin with barely any harm at all, coexisting with it apparently for a very long time. The genetics told the story. The North American outbreak traced back to a single introduction, one clone of one European strain, almost certainly carried across the ocean by human travel or trade and released into a population of bats that had never encountered it before and had no evolved defenses against it. In Europe, bats and fungus had fought to a long truce over thousands of years. In North America, the fungus met millions of defenseless animals all at once, and the result was slaughter. It was, in the end, not a natural disaster, but a human one. A pathogen moved by people across an ocean it could never have crossed on its own. And that same brutal logic is where the faint outlines of hope begin. Because if European bats learn to live with this fungus, then perhaps, given time, some North American bats can too. In a handful of places where the disease struck earliest, biologists have watched small numbers of little brown bats begin, cautiously, to persist and even rebound. Survivors of the massacre that may carry some trait, some behavior or biology, scientists have raced to help them along. Teams have tested treating cave walls with UVC light to kill the fungus, the same sterilizing technology used in hospitals, in a device the size of a fire hydrant that can disinfect a chamber in under 2 hours. Others have developed a vaccine and begun immunizing wild bats against the disease, spraying or feeding them a treatment that primes their immune system. An effort already underway in caves in states like Idaho, and have experimented with probiotic bacteria drawn from the bat's own skin that can slow the fungus's growth. None of it is a cure, and the disease is still spreading into new territory almost every year. But for the first time, the animals are no longer entirely defenseless, and in a few long-infected regions, the grim, unbroken decline has finally begun, in places to level off. In the end, it comes back to that single photograph in a New York cave in February of 2006, a picture of a few bats with a little white dust on their faces. An image so unremarkable that no one understood at first that they were looking at the opening frame of a continental catastrophe. What those bats revealed was not just a new disease, but a hard truth about the age we live in, that a fungus carried carelessly on a boot from one continent to another can undo millions of years of life in the space of a decade, and that the small, dark, unglamorous creatures we so rarely think about may be holding up far more of the world than we ever realized. The bats did not vanish because nature turned against them. They vanished because something was brought to them. And whether they come back now depends on whether the few survivors hanging in the dark can do what we could not and learn to live with the thing that was sent to destroy them. And if you want more true stories like this one, where the smallest and most overlooked lives turn out to hold up the world around them, subscribe and the next one will be waiting for you.